Good morning. It is 1 minute past 11, so we might start our webinar today. Welcome to the Designing and Building Marine Infrastructure webinar. I'm Kelly Stewart, Marketing Manager at Wagners CFT, and I'm here with Business Development Lead Darren Wilson and John Leman from International Marine Consultants. John is also Chair of the Technical Committee for Standards Australia on both the Marina Design Standards and Design of Maritime Structures. Before we get started, just a few webinar protocols. We are recording today's event and plan on making the recording available to people who are unable to attend via our YouTube channel. We're going to run through Darren and then John's presentation first and hold any questions that you might have until the end. You'll see at the top of your screen in the navigation bar, there is a chat tab where you can submit a question anytime during the webinar, and I will compile those questions for discussions at the end. Also, I'd like to flag that at the end of the webinar, we will circulate a feedback form. It's really quick to complete, and the information you provide will help us continually improve our webinar series. So without further ado, I would like to introduce Wagners CFT Business Development Lead, Darren Wilson.
Thank you, Kelly, and welcome everybody. Kelly, you might just have to allow me to share my screen, please.
Just one moment. Do you need me to share your presentation?
That'd be great.
Or just share your screen?
I can share my screen, please, if I can share my screen.
Can you see that? Your presentation?
Yep, absolutely.
All right. Okay, you right to go?
Yes. Will you be flicking through the slides, Kelly, or will I?
Either way, you should be able to do it just from the bottom of the screen, but happy to do it for you.
All right, looks like I got control. Okay, so welcome everybody. Welcome to today's Wagner webinar, which is on designing and building marine infrastructure with FRP versus traditional materials. What are our marine customer needs? So we're focusing on durability, looking at the innovation for durability, minimal maintenance, cost competitive and budget friendly total cost of ownership, environmentally sustainable conscious considerations, flexible design options, smart and efficient installation methods, Australian manufactured product and manufacturing, design for Australian codes and condition, and also customer service. Our durability. We're promoting a strong 100-year design life. The product and the FRP is resistant to rot, rust, corrosion, and acid sulfate soils. It is termite proof, designed and engineered to AS standards, and building infrastructure projects for a better future. Minimal maintenance. So we're pushing with the total cost of ownership from a 7-year structural warranty point of view, 25 years to first maintenance on coated elements exposed to direct sunlight, 40 years to the first site main maintenance and engineering inspections, the cost effectiveness of those projects, and the product being FRP being extremely resistant to corrosion and rot. Total cost of ownership, cost competitive and budget friendly. So the total cost of ownership breakdown, it equals acquisition plus operation plus maintenance costs, which is ultimately the salvaging value. So from the total cost of ownership from an asset management and asset maintenance point of view, we're looking to significantly reduce maintenance by using the innovation and technology of FRP, which is helping also to reduce the replacement costs from a short to medium to long term. And again, total cost of ownership. More cost competitive and budget friendly comments. So in the industry, we're seeing increasing costs and declining availability of traditional materials. So in turn, Wagners CFT and our FRP products are helping to overcome those challenges. A lot of materials that we currently use here in the industry are made overseas, brought into Australia, and that can incur on some occasions and most occasions long lead times associated to that project or specific job. Being a made in Queensland product or a made in Australia manufactured product, we're able to significantly reduce those lead times and helping to maintain and meet programmed practical completion dates for both contractors and asset owners. The increasing costs and declining availability of skilled contractors to perform maintenance and repairs. So overcoming that by significantly reduced maintenance requirements, again, going back to the total cost of ownership, utilising and pulling on the FRP technology and innovation. Increased installation costs and time, so the non-modular design and being heavy with traditional materials. So the flip side of that, by using this type of innovation and technology in the maritime sector, is working through a modular yet lightweight process with the materials that we manufacture. And this can be incorporated and be prepared in a fabricated off-site application, but also be pre-modularized on-site and then lifted into place with very light machinery. The longevity of structures. So again, 100-year design life. So a part of the 100-year design life, breaking that down, is achievable due to the internal ongoing testing that we've started back in 2002, where we began in this FRP journey. So up to today, we're continuing to do a significant amount of internal R&D and internal testing on our current profiles and up and coming profiles. Environmentally sustainable and conscious. So the products are non-leaching. They will not release harmful substances into the environment, suitable for all areas of high conservation value and marine environments. They're inert, so chemically inactive, and they will not react to moisture, chemicals, and UV radiation. Infinite resources compared to hardwood timber and steel, which are getting difficult to source from finite resources. Continuing on, so from a reduced carbon footprint point of view, we know that the embodied carbon from an FRP characteristic is 5 to 7 times less than the equivalent to timber and steel structures, for example. Our FRP has an EPD, which is currently being independently verified. Flexible design options in the maritime sector, jetties, gangways, fishing platforms, boat moorings and marinas, floating pontoons and wharves. Smart and efficient installation. With the FRP, you're considering the fact of the product being lightweight, so it is 50% lighter than timber. It's modular in design. It can be prefabricated off-site, reduced excavation for footings. Now, on the right-hand side there, we've got a photograph, and whilst it is a boardwalk, it's still in that marine type environment, so it's right along the coastline. And one of the considerations from the asset owner's point of view, right from the very beginning in the prospect stage, to think about what could be achieved, there was an existing project there, and the footings that you see in the photograph there and the cleats that you can see obviously are something that we've reused in this project. And due to the lightweight nature of the FRP, we've actually been able to increase the width by utilising the same footings also. So we've actually increased the space for people to be safely, from a DDA compliant point of view, passing one another. So it does lend itself very user-friendly to that type of design and engineering characteristic. Designed for Australian codes and conditions. So we're occupational health and safety ISO 45001 compliant, environment ISO 14001, quality ISO 9001 from a quality QA point of view. And on that, we have a significant amount of internal inline testing of the material, and we also have an independent quality QA division within the business. Environmental Product Declaration, so the EPD, and AS 4997 guidelines for the design of maritime structures. As mentioned earlier, we have an in-house research and development team. We're very proud to be growing that division within the company, but where we started from back in 2002, we're seeing a significant amount of data uptake, and that in turn enables us to improve the product and release more innovation and technology to the industry. We have an in-house quality assurance team, as mentioned, and from the very beginning of the process where the product's manufactured in Queensland, we can, once it's complete and out in the field, from a production number or traceability number, we can actually trace back all the processes and all the materials that are incorporated into the product. At customer service and follow-up care, so we have and promote strongly a 150 plus staff in Wagners CFT. So we service also every state in Australia plus New Zealand. The product is manufactured at Wellcamp facility in Queensland. We have an in-house specialist team of employees, so SMEs and expertise in all areas of the business, subject matter experts. Engineers, so from plant engineers to structural FRP engineers. We have civil engineers, so we have a full suite of capabilities in that area of the business. We have drafting and design capabilities in-house. And on drafting and design, we also have a design guide that has been out to the market for a little bit of time now. And what's interesting is that we're also very transparent with the calculations and the modulus criteria and characteristics of the FRP. So for engineering consultancy firms that are out there, we're very keen to work with you in the drafting and early stages of projects and provide collaborative synergy in working together to get any challenges that you might be facing on your projects across the line. We also have as mentioned, an R&D team with the full in-house capacity of destructive test capabilities of all products. We have a QA team and an installation team for all materials. Touching on a few examples in the maritime sector. So this is our Wagners Pinkenbar Wharf in Brisbane along the river. This project is one of the most innovative wharf structures in the world. And this enables a lot safer passage for vessels to travel up and down the Brisbane River. It's positioned alongside our Pinkenbar cement powder facility, and it's world-leading innovation. The detail on the right-hand side there, if you have a brief look at that, that utilises our FRP U-girder technology. So in turn, that's actually our 125 SHS box section bonded together. And that's essentially acting like a weld line to create stiffness and durability in the dynamics of the project against steel, which is a lot stiffer and more rigid. It has a composite flat on the bottom that's also bonded and laminated to the FRP. And once put into the molds, it also utilises touching on the Wagners EFC earth-friendly concrete, which has zero cement content. And on top of that, we've actually incorporated the GFRP rebar instead of steel reinforcing rebar. So it's a 100% non-corrosive bridge deck system in that wharf. It officially opened in 2021. It consists of 573 U-girder sections. It had 350 kilometres of FRP reinforcing material and 500 FRP fascia panels. East End Boardwalk in Townsville for Townsville City Council. Part of this project was to replace what was a very small section along the river there of an existing timber asset. And with integrity testing and load testing, we were able to utilise those existing timber piles, but further down the boardwalk, we had to install brand new piles in that project, and then we built a modularized FRP truss under deck system, which was lightweight and easy to install across from the land. It does run alongside the Flinders Street precinct, and eventually there will be full connectivity back into the Townsville Stadium. All FRP material, along with the millboard copper oak decking. San Angelo Pier in the USA, fully independently an FRP structure from a materials point of view. A couple of highlights here are that you can see in the top right-hand photo, we're vibrating our FRP material into the waterways there, which is allowing a strong foundation for the fixed project or structure to be built on top, utilising all FRP. The connection detail, and what's interesting here with our technology is that we do promote in the maritime sector all 316 grade stainless steel connection detail. And wherever there is a bolted connection, we do insert what we call an actual crush block that actually increases the connection compression capacity with any connection detail with the FRP structures. So it's very innovative technology, but it is again leaning towards that 100-year design life for any of our structures that are engineered and certified. What else we do? Touching on a little bit here. So these are light poles, and we do FRP light poles. So this project here was for the North Queensland Bulk Ports Corporation in Mackay. It consisted of 17 5-metre with 2-metre outreach poles. The outreach arms are also our profile as well, so completely FRP solution, completed FRP solution. There was also 12 8-metre tall with 2-metre outreach poles, utilising existing footings and rag bolts. So one of the biggest challenges we faced here was, what does that look like from an integrity and load testing point of view with those existing footings? And with that testing being successful during that course of early stage site investigation, we were able to save the client, the end client and asset owner, significant monies on full replacement. So they didn't have to go digging up the foundations and footings. And it is cyclone rated as well. Okay, so at this stage of the webinar, I'm very proud to introduce our guest speaker, who is from International Marina Consultants, IMC, John Leman. So IMC specialises in planning and designing marine structures and integrated waterfront development projects. They have more than 40 years experience in investigation, planning, feasibility, appraisal and detailed design of modern marine facilities. They've worked throughout the world on developments in New Zealand, Malaysia, Singapore, Indonesia, the Philippines, Hong Kong, China and the UAE. They're the current chair of the Technical Committee for Standards Australia for both the Marina Design Standard AS 3962 and Design of Maritime Structures AS 4997. So without further ado, I would like to introduce John Leman from International Marina Consultants. Welcome, John.
Thank you, Darren. Morning all. You probably need to allow me to share the screen, Kelly.
You should be able to just share the screen at the top, John, with the share button.
Yeah, it's just not allowing me to do that.
Okay.
So you just got to allow me to share. Otherwise, we can go to you running the PowerPoint, but just see if you can allow that for me to share it.
Sure. Give me a moment. I'll just pull up your presentation.
Okay. Yep. Yeah, for some reason you've got to allow me in to share the screen if I do it.
All right, you should be able to see that now, John.
Yeah, yep, I've got it here. So yeah, and I can operate. That's fine. Obviously, looking at with the theme of designing and building sustainable marine infrastructure, and some of the important things in sustainable in the marina environment is obviously making sure that it's got the decent sort of durability in the harsh marine environment. And to that end, materials considerations in the design process are pretty important from the onset of your design process. Durability and maintenance costs have just been so much further highlighted by particularly the significant increases in maintenance and repair costs that we now face in today's environment. And then also it's further complicated by sort of the heightened requirements for health and safety and environmental harm minimisation. So what we did in forming the committee for AS 4997, just go through what we need to focus on. The original standard was written about 20 years ago, and we identified that there was needed a lot more emphasis on materials, maintenance and durability. This standard, we just finished our sort of committee editing of it, should be going to Standards Australia for their final edit and hopefully out for public review in a month or so. And part of that highlighting of what we needed to do in that was just there's a lot more old structures around now that are showing signs of requiring maintenance. And we see that more of an issue probably than the actual structural design. It's more durability. So again, this is why we're focusing on that. And just to sort of give you some examples, many, if not most, of the structures that we're doing in the marine environment are they've got issues with their durability, but piled structures. Piles are a bit harder to remediate, so there's plenty more examples of bad-looking piles around. So, and I'm just going to focus on that just to highlight some of these issues. Typically these piles are timber, concrete, or steel, or have been in the past. So, as I say, durability in this marine environment is the big problem. So, if we look at timber. Typically, the problem we have with timber is the marine organism attack, and there's plenty of examples of that around Australia and worldwide. And it's being exacerbated a bit by the fact that we can't put as much and as nasty poisons that used to be put into treatment. So, that problem is only getting worse. And the one on the left there is South Mole Island, which I didn't expect inspection of that about 5 years ago. And, I was getting to within about half a kilometre of the jetty, and I said, I think what the outcome's going to be from the inspection. And I've got a case study of the redesign of that, towards the end of the presentation. But, you get other examples that are all too common. The one on the right there, where they've just sort of put a pile in next to it and put a bolt through and sort of just leave it at that. There's other ones that you can go to. You can see here they've done some sort of makeshift temporary repairs, but then they sort of get forgotten about, and they asked me to inspect this, and I said, I hope you don't expect me to go under there, because there seems to be air holding up a lot of that jetty, but just highlights that problem that we have with timber. So concrete piles is another that we often used. And I'm just sort of concentrating on more lightweight structures rather than heavy port infrastructure. But typically the concrete piles for the lighter structures have been done by hollow spun reinforced concrete piles. But even so, they're still quite heavy to handle. If we're looking at bearing piles and we're driving to a set and the soil conditions are a little bit softer than what the investigations say, they might need a bit of an extension. And of course, that's very difficult to do with a precast concrete pile. But also the obviously chloride ingress and reinforcement corrosion, a big issue. And just some examples here. The one on the left is probably the worst pile I've ever seen, where it's just blown all the concrete off and you can see the badly corroded reinforcement. See a lot of what's on the right there are the beginnings of corrosion, because typically these piles are designed for a 25-year design life. and there's a lot of stuff around that's a lot older than 25 years, and you can see there it's sort of getting towards spoiling the concrete right off it. They have tried to do repairs with these piles, but the chloride's really got right in and behind the reinforcement. So even though you can scabble it all off and epoxy repair it, still usually blows the repair off over a short period of time. Just looking at steel piles, which more common option nowadays, but obviously you need to corrosion protect the steel piles. In the past, it's been a paint system or high build epoxy. But of course, when the pile drivers are putting these piles in, they're subject to getting damage and a bit hard to repair a paint system if it's in the tidal zone or under the water. A lot of systems have anodes on them, but of course the anodes only work in the wet medium for cathodic protection. So it's only good for below mean sea level, and we get a lot of corrosion in that upper area splash zone and tidal zone. More popular of late has been putting HDP sleeves over steel piles. Which they work in sealing, driving into the bed and sealing the top. So we work on oxygen depletion. My issue with that is that we never know what's happening behind the HDP sleeve. If you've just got a very small pinhole in the pile somewhere, then during the day when it heats up, it sort of blows the air out, and then during night it sort of sucks in fresh air, so we won't necessarily get that oxygen depletion if there's any flaw in that sleeve installation. The other thing that's become more prevalent is microbially induced corrosion or accelerated low water corrosion. This is actually first found in the States in sprinkler systems in buildings, where they just had a sprinkler system that started to get little wet spots or leaks in it, and they couldn't understand why. It was actually this anaerobic microbe that was causing the problem. It's in our marine environment, it's probably more prevalent in the in sort of nutrient-rich seabed materials and harbours, and of course being lower water corrosion, quite often it's sight unseen, but it's becoming more of an issue. Just got some examples here of this marina is over 30 years old, but we've got the high build epoxy coating that's sort of degraded over time, and the one on the right there is a bit of microbial action, I suspect, as well. It's just a hole right through the pile. And another example there where probably we could say that the epoxy coating isn't doing too badly, but it's just these localized corrosion areas, and that have got to extent in this case where it's right through the pile. And then of course you've got corrosion on both sides, both surfaces of the pile, inside and outside. What we did with that one, we did do some HDP sleeving in another steel pile on the inside, because it was economics that drove that. But on the right-hand side, you probably see in the distance there's some piles with white pile caps on them. They're actually concrete piles. So the solution there was to actually put an FRP, fiberglass pile on the outside of it, and that worked really well. We probably did those about 5 or 6 years ago, and good outcome. I just want to go now just to the case study of South Mole Island jetty replacement. I showed you that picture of the eaten out timber, but when we did this a few years ago, we really concentrated on getting a very long life structure and using materials that would achieve that long life, no maintenance. So we've got FRP piles for this jetty, this fixed jetty. we've got FRP headstocks, similar to Darren mentioned those ones for their bigger bar jetty, but similar scenario here. Then also FRP reinforcement in the concrete decks. So we wanted to achieve a fixed wharf structure with no carbon steel, which we did, and interestingly enough, it didn't cost a lot of extra money to do it, if any. Just an example of the piles, and these are the FRP piles that we used on this job, and just to show that you can quite easily do extensions to them. So that's just actually done in a factory situation of an extension. This is one of the earliest jetties to have fiberglass piles in Australia, so we were quite interested in how the thing would go with pile installation. So the upper part where we couldn't get the piling barge in, it was too shallow, so those were put in by vibrating hammer. A fairly lightweight excavator there because it's on an island and they don't just have availability of a lot of big gear, but they worked really well vibrating them in. That's just a picture of all the FRP reinforcement in the deck slabs, which are pretty thick because we actually, in this case, in a cyclone, we can actually get waves slamming underneath the wharf deck. So they're pretty hefty and heavily reinforced in this situation. Here was just the outer part of the jetty and driving piles with a drop hammer, which was 2.5 ton drop hammer, and they were dropping it up to 1 metre where they struck some sort of coral objects in the bed and had to get them in. And where they did get some serious resistance, it was they were really belting these things, and it's amazing how well they stood up to the hiding that they were getting. So you can see that picture on the right. They're all looking pretty good, the tops of those piles. And some of those inshore ones you can see are low because there was a little soft spot there. So that's where they had to extend the piles, and that worked well as also. So that's just completed jetty looking underneath it out to sea. You can see there's three deck slabs there. That was purely driven by what the piling contractor could lift and put into place, because they're pretty thick slabs. But you've got the fiberglass FRP piles. You've got the FRP headstocks that are all bolted within the system, and then the FRP cross bracing with the stainless steel bolts going through the piles to tie them together. My first inspection, I noticed a bit of rust just under where the stainless steel bolts were, but actually they used a diamond core bit on a steel mandrel, and it actually put some steel, left some steel on the hull, which I'm a bit disappointed that we saw a bit of rust coming there, but it wasn't sort of anything to do with the materials that were being used. So that's the completed jetty there. And then you've just got a floating pontoon at the far end of it. But you've got a fixed jetty there that's no maintenance, no carbon steel, so it's going to be there for a very long time. And as I said earlier, there was no real cost impost in going for all these materials. Be it piling, the Rio, the headstocks. It was all, nowadays, to me, if there's anything that should be taken home from the presentation, is that you don't have to be looking at a huge cost increase to go to more modern materials and get a good life result out of your fixed or your floating jetties. You'll see the pontoons lifted up out of the water. This was a bit of a unique design solution at the time, where this South Mole Island, this beach faces north, and during a cyclone, it could possibly get waves up to 4 meters high, breaking waves. So there was lots of talk about how we could do a pontoon and how to deal with it in an extreme cyclone event. The reason that we do pontoons is just for, we can't do old jetties with steps anymore. It's got to be a floating pontoon with a degree of disability access. So this pontoon lifts right up, and you can see up the top of the piles there's actually solar panels up there, and there's a battery pack and electric motor, so they can lift these things, or they lift the pontoon well clear of the water, and it's completely autonomous. So whatever happens on the island, the power failures, whatever, this thing is all self-contained, and we can actually raise it and lower it 3 times on the battery power that we've got in there, and it actually recharges on the way down again. So it came up to be a very good solution. I was fairly insistent that we weren't going to have a system where, we'll just take the pontoon away just before the cyclone arrives, because I've never seen that work yet. And the other thing is that we did want something that was ready to use as soon as the cyclone was over, because there's always things that need to be done pretty quickly after an event like that's gone through. Just as an aside, I see earlier this week that the resort area is for sale. So it's got very degraded, broken down facilities on land, and Cyclone Debbie sort of went through there, but at least it's now got a very good jetty to use to redevelop the resort. Thank you very much.
All right, I'm just stopping that. Yeah, just stopping that presentation. I just wanted to remind everybody, if anybody's got any questions for Darren or John, just pop them in the chat facility at the top of the navigation bar there. And I will make sure that the guys see those questions, and we can answer them. Darren, we do have a couple of questions actually that have come in prior to the webinar today. Can you tell us a little bit how we nominate the 100-year design life?
Yeah, sure. So basically, there lies the 100-year design life, and we've basically undertaken accelerated testing through the structural properties, mechanical properties, coating materials for the FRP through a UVB testing cycle. So it essentially goes through up to 40,000 overturned life cycle, which gives us that data, along with the destructive testing that we're able to undertake to meet the applications in the engineering and certification of where the projects will be installed.
Thanks, Darren. We've got a first question that's come in there from Todd Irvine. Todd just wants to know, there's lots of design methods for steel and concrete structures. Todd would like to know what do we have for designing for FRP?
Perhaps I could answer that one. Just from my side of it, my understanding is that they are developing up a design standard for composites in Australia, but that's a little way off yet. But we actually use a European Eurocomp standard that is used for, that's a design code and handbook for polymer composites. So it's a European standard. If you'd like some more details on exactly which one it is, and how to go about getting it, then just send me an email, and I can go into more detail.
Yeah. So it's interesting to lead off the tail of what John's just mentioned too, because whilst there isn't an Australian FRP standard governancing what compliance we've got to meet there's definitely the Eurocomp standard that we work through and work by for FRP.
There's also,
Great.
just a little bit further to that, there's also a standard for fibre reinforced polymer bars in concrete, and that's an American Concrete Institute standard that we use when we're looking at FRP reinforcement.
Thanks, John. I'll make sure when I send out the follow-up email to everybody this afternoon as well that I include yours and Darren's contact details. So if anybody has any qualifications or follow-up questions to today's questions, you'll be able to get in contact straight away with John and Darren. We're going to go to Maverick Penman, has just asked the question, are there any existing jetties piers built from Wagners FRP in Victoria or New South Wales, Darren?
Yes, there is, and we would be very happy to send through to Maverick and everybody, but Maverick has asked the question, so thank you so much, Maverick. Though the list of those projects for you to either go and inspect or make reference to and lean into what has actually happened once you've been to site for the installation of those. So very happy to share those with you.
Great. Maverick, we'll be in contact with the locations of those jetties and piers that you can go and have a look at in Victoria and New South Wales yourself. We're going to go on to the next question. So for inspection, what is the frequency recommended?
So standardised, I guess it's simply, excuse me, it's up to 40 years first site main maintenance inspection, and that comes down to that cycle of total cost of ownership to the 100-year design life. We give a 7-year manufacturer's warranty on all the manufactured FRP materials. We also give a 25-year resilient warranty against UV. But from a structural capabilities point of view, we do maintain and hold a 40 years to first site main maintenance inspection on any installed, engineered and certified structure using the FRP.
Thanks, Darren. Nothing to add there, John?
No, look, I don't think so. It's, we're looking at structures in the Great Barrier Reef, for example. The Great Barrier Marine Park Authority asks for it to be anything to be inspected and signed off once a year, so we're well over covered with that one. But I think that we're pretty much in line with what Darren's saying about the time for inspection, for time for first maintenance.
Great. We've got about 4 more questions to go there if everybody's happy to continue. We have a question from Laurie. FRP concrete piles. Are they using FRP piles as permanent formwork and install Rio and fill with concrete to form an FRP concrete piles? What's the benefit of these FRP concrete piles?
Look, I'm not aware that they've used an FRP liner and then poured concrete. I haven't been involved in any of those type of scenarios. It's really just, by the sound of it, using an FRP former to then have a reinforced concrete instead of the steel, and then cleaning out and putting the cage and concreting in. So, but I haven't been involved in anything like that to date.
Great. We'll take that one on board, Laurie, as well. And if we find out any more detail for you, we'll make sure we circle back on that one. Ben Cook just wants to know, does the polymer for the FRP incorporate any recycled plastics? And what happens to the FRP at the end of the design life? Can it be reused or recycled? I think, Darren, that might be a question for you.
Absolutely. Thanks, Ben, and really good question. So we've really dived into this space a lot more of recent, since everyone started focusing in the industry for materials being recycled and being earth friendly or environmentally friendly. So in our FRP, it's a fluoro reinforced polymer product. So we incorporate all virgin type materials from the first day of when it's made. And at the end of the life cycle, when it's broken down from the fibers versus the resins, recognizing that we have a 76% glass content and the remaining being resin, which is one of the highest in structural FRP products in the world. the fibers, once broken out from the resin type materials, the vinyl ester resin that we use, it is typically incorporated into either road-based structures or fibre reinforced concrete type elements and ingredients. Then what happens is with the resins, it's basically used in body type fillers, or again, like those road-based type materials. So there is an end of life use for the product, but again, like it's continuing to develop and evolve, even to this point where we've come from way back in the beginning. And FRP, it has been around for a long time, and I think we're seeing significant traction in the space of not only being one of those very longer lasting infrastructure type structural materials and elements that are being used everywhere now, but it's also hugely of conversation and topic to consider what happens at that end of life cycle where we're talking 100-year plus design life. So yeah, I hope that answers the question.
Thank you. We're getting some thumbs up here, so I think you've answered the question. Last question. Gian would like to know, is the failure mechanism brittle? Can you see the sign of overstress?
Okay, so John, you can also jump in here if you want, but from a tip load or a 4-point bend test point of view or significant impact point of view, it's unique in how the FRP from Wagners' point of view is actually manufactured, with being different, that when it does receive a significant impact or load hit, if it's to the point where it is actually fracturing or failing, that's quite a significant impact. And what we tend to find is even through internal destructive testing and simulating what may happen out in the field, the pile or the structure will maintain a level of structural integrity and strength to the point where the fibers actually, because it's longitudinally formed as well as coaxial transverse winder formed in between each individual layer to get that wall thickness of the pile, it actually does retain a certain level and percentage of actual integrity and strength. So whilst it will, show that sign of fracture, if it's to the point where it's actually failed, if that were a steel or concrete pile, for example, it would shear and it would collapse and the structure would fall. Whereas with the FRP, there's a lot more integral properties incorporated and technology to withstand an impact against, comparing it to steel or concrete.
Thanks, Darren. Anthony Dean would like to know, what are the repair options available if sections are damaged?
Okay, so
just the second last question there on the chat, Darren. What are the repair options available if sections are damaged?
So because of the modularized type elements that we typically work with in engineering and design of the structures, and as John's project and case study highlighted, the bolted connection detail allows that if there is, for whatever reason, a significant impact, the distributed load could be, in most cases, I guess, carried by the other piles and the other segments, and it could be quite easily unbolted and removed and easily reinstalled and reinstated with new material, as opposed to traditional material where you'd have to pretty much demo and completely rebuild. So there is quite a modularized repair system that, again, comes into play with technology and innovation from FRP.
Yeah, I think I'd just add on to that, is that we're looking at a resin and glass-based substrate, so you can actually repair. Like some of the classic examples would be fiberglass boat repairs, where they're getting in there, they're grinding out, and they're laying up and resining back in a repair if it's a localized sort of failure. And some example of that I showed was where we were connecting piles, we were extending piles, where it's just using a good quality adhesive or resin, and bonding some more material into there.
Thank you. I'm just going to remind everybody at this stage, I'm conscious that it's 50 minutes past 11 or 10 to 12. If you do have to go, we are recording the session today. I will make it available on YouTube and send it around to everybody this afternoon. There are two questions still there, so we'll just persevere. If you have to go, you can return back and watch the recording later on. In the meantime, we'll press on and just answer these two questions. So Todd Irvine has just asked as well about the grid mesh. He said that something came up recently in a project where the FRP grid mesh got challenged by government agencies due to concerns with polymers or microplastics entering the water through wear and tear. So can we talk to that one, guys?
There's a yes and a no response there, Kelly. So that's an evolving conversation. I totally agree with Todd, and thanks for the question. I guess to give a bit of clarity here, there's multiple versions of FRP decking, and to give complete transparency, we actually have done a significant amount of internal testing and do so ongoing with any receivable decking FRP products. And what we found is with the cheaper version of FRP decking, whilst it'll look the same or exactly like a higher quality upper end market type of FRP mesh material, it through a high frequency pedestrian pathway, it'll actually break down. And exactly as you've alerted to there is a risk of it actually potentially going into the waterways. And with decking that we are using on all of our projects, it is what I would class as definitely the top shelf FRP decking, and that's purely due to the types of resins incorporated with the fibres when it's actually mixed and poured into the molds. So we are doing that skin friction type testing for that type of product, and we'd be happy to share information to give you that level of confidence and go back to your people to explain that in more detail or be a part of that conversation.
Great, thanks. Darren, we'll follow that one up for you, Todd. Final question from Stephen Pottinger. How thick are the walls in the pylons?
Okay, so thanks, Steve, good question. And depending on the profile size, so typically if you're driving piles for a 230 mil, you're looking at around about 12 mil. But if it's over the 230 mil, up to 301 plus, like obviously the larger the profile, the thicker the wall. So the 301, for example, is a 13 plus mil wall thickness. So I guess when we're designing and developing our profiles, they're essentially engineered for a certain application. So we take marine piles, where very much so on this very what would you say, very high uptake for an appetite to work with our products in this space. So we're continuing to accelerate the internal capabilities to release larger profiles as we keep moving forward in marine pile applications. So whilst there's a high demand and high call for FRP, we want to keep developing and evolving. So the wall thickness varies from profile to profile.
Yeah, it depends on manufacture. Some piles are, they can be a lot thicker if they use a different process. But then again, using, say, something like filament winding, they're not to the higher standard of your pultruded product. So it's just not sort of comparing apples with apples as far as wall thickness goes. But those piles that I showed you for the self-mould jetty were about 15 millimetre wall thickness.
Great. All right, well, I think that concludes today's webinar. Thank you so much to our guest speaker, John Leman from International Marine Consultants, for attending today and sharing your extensive knowledge with us. Greatly appreciated. And obviously, thanks also to Wagners CFT Business Development Lead, Darren Wilson. I'm just quickly going to share this screen with you so that you can, if you have the time now, help us with our feedback on our webinar. If you use that QR code, it will take you to a webinar feedback form. Your feedback is vitally important to us because it helps us improve our webinar series to you all the time. And I just wanted to let you know as well that today's webinar concludes our series of August webinars. We are looking to bring you a new series in October, and we will notify you of the date and theme in due course. So thanks for coming today. That's the end of our webinar now. Goodbye now.